Welcome to Local Heroes from Linlithgow, the birthplace of Mary Queen of Scots. I've come here because this week all my heroes come from Scotland. This is the parish of Keir, 14 miles north of Dumfries. And I've come here on my bicycle to Courthill Smithy because it may well have been in this very building that my next hero invented the bicycle. His name was Kirkpatrick Macmillan. Kirkpatrick Macmillan was born here in Keir in September 1812 and became a blacksmith like his dad. He probably went off to work in a foundry in Glasgow. Then he worked for the Duke of Buccleuch, who had a nice little place up the road, before returning to Courthill and taking over the business when his dad retired in 1851. Now, it says on his gravestone and on this plaque here that the first bicycle was built in this very place about the year 1840. And it says on that plaque it was built in 1839, so there is a certain amount of doubt about the invention of the bicycle. We do know that in 1817 a German chap called Carl von Dreis patented a thing called the hobby horse, which had two wheels and a saddle in between, and you sat on it with your feet on the ground and pushed yourself along. And they used to wear out their shoe leather and indeed the iron they put in the soles of their shoes. But everyone who's anyone had to have one. It was very popular. However, the next stage in the development of the bicycle did require a real leap in the imagination. The thought that you could balance on two wheels and propel yourself with some sort of mechanism. The first pedal-driven bicycles were supposed to have been made in the 1860s by Michaud in Paris. They were called bone shakers or velocipedes. The ordinary or penny farthing came along about 1870. There's no mention in the official history of Kirkpatrick Macmillan. According to the plaques, though, this was where he built the first bike, and this is it, or at least this is a modern replica. You can see it's got a huge solid wooden frame, wooden wheels, iron tyres for surviving on the roads, and steering, well, much like a modern bicycle really, with handlebars, but it doesn't steer very much because the wheel runs into those iron rods there. Now the back wheel is huge and again wooden, and it's got these cranks here which turn round as the wheel turns. And they're actually turned round by the action of the feet on these treadles down here, which go backwards and forwards instead of round and round. And that's a slightly unusual motion to get used to. Now, the question is, can I ride it? Well, get astride. I'm going to give a good push off and then push with my right foot and then try and treadle. Ooh. It's a very peculiar action. It's extremely heavy. The steering's very limited, but I do seem to be going forwards. Macmillan didn't bother to patent the design and indeed seems to have done little with it, but others saw his bike, copied it and sold the copies for £6 or £7. Apparently, Gavin DL's copies became so well known that for years he was regarded as the inventor of the bicycle. Well, there may be some controversy about who really invented the bicycle, but I'd like to salute the ingenious Scottish blacksmith who built the powered velocipede, Kirkpatrick Macmillan. I've come to these Arctic wastes to tell you about a pair of brothers whose work revolutionised the way we think about temperature. The younger laid the first cable under the Atlantic Ocean. He set up the world's longest running experiment, and he found that there was a temperature below which you could not get. Nothing could ever get colder. The elder one worked out the physics of ice skating. They were the Thompson brothers, William and James. Although James and William never went to school, both went to Glasgow University when only 10 years old. James became an engineer, while William went on to study physics. James Thompson noticed something very peculiar about ice. It's very hard and brittle, you certainly can't bend it. And yet, if you go to Switzerland and look at the glaciers, they flow down the valleys with a smooth, sinuous movement going round the corner, so they must bend. They flow slowly, but they definitely flow. Now, he discussed this with his brother William, and he thought maybe there was something to do with melting going on. And William devised an experiment. Down here, I've got a bucket of water, which is just a heavy weight, and it's hanging on this guitar string, a very thin piece of wire. And this is hung over this block of ice. And you can see that it's cutting into it. Look, it's halfway through. The The ice is continuous, there's no gap there, and yet the wire is at least halfway through it and gradually cutting through. And what's happening is that under the great pressure caused by that bucket of water, the ice is melting. It's not getting warm, it's melting because of the pressure. And he reckoned that must be happening with the glaciers too. As they come down and hit, say, a lump of rock, they'll melt a bit under the great pressure, and then as they get soft, because it's water, it goes round the corner and then it refreezes on the other side and the ice goes on down the valley. And what's more, that's part of the reason why ice skates work, because here I've got a very, very thin edge on my skate, and I calculate that if I put that on the ice and I tread on it with all my weight, I'm exerting a pressure about 60 times the atmosphere, which must tend to melt the ice into a thin layer of water, which is a wonderful lubricant, which allows me to sail along with a smooth, glidey style. But I suspect that friction is important too. As the solid blade moves over the ice, it must generate heat, and that would also melt the ice. But I don't know which is more important, friction or pressure. So if any of you know, please write to me and tell me. Or even better, can you devise an experiment that would work out which is the more important, friction or pressure? I'll tell you how to get in touch at the end of the programme. This is the River Kelvin in Glasgow. And when the younger brother William Thompson was made a baron, he called himself Baron Kelvin of Largs after the river. Now in 1837, Cook and Wheatstone had pioneered the electric telegraph. And by the early 1850s, it was possible to send telegrams all over the empire, but not, unfortunately, to North America because of the Atlantic Ocean. But in 1855, William Thompson brought America within telegraphic reach. So, I'm going to lay a transatlantic cable. Well, actually a trans-Kelvin cable. At the other end, my cable is connected through a 1.5 volt battery to the Earth. So what I'm going to do now is to check and make sure it hasn't broken. This is what Kelvin did constantly. So with this, I'm going to connect to the Earth through the water, and with this end, I'm going to connect to the end of the cable. And yeah, I've got a lovely signal, so I know that my cable is intact. The first cable, laid from the Agamemnon, snapped. The second cable seemed to work, but they ignored Thomson's advice and used high voltage, which attacked the insulation. Only 732 messages got through. He used the Great Eastern to lay a third cable, which broke after 1,000 miles, and permanent communication with the USA was finally achieved on the fourth attempt. William then set up the first ever physics laboratory here at the University of Glasgow. He was interested in heat. This rather grand room is now the Senate room, but it used to be Kelvin's laboratory. He was really interested in a heat phenomenon, first discovered and described by the French scientist Jacques Charles. What Charles discovered was that if you take a balloon full of gas and cool it down, then it shrinks. I've got two balloons here, as near as I can do, it's identical in volume, and I'm going to put this one into this beaker here, which contains liquid nitrogen at minus 196 Celsius. And he actually discovered that it shrinks for every degree you lower its temperature by 1/273rd of its volume. There, you can see it's shrinking away now. And Kelvin realized this was very odd, because if you cool it by 273 degrees, the volume should go to zero and the gas would have to disappear, and that was obviously impossible. And then he realized that he was thinking about it the wrong way. What he should be thinking about was the energy. Now inside here, there are loads of particles of air whizzing around with masses of energy, and it's that whizzing around that makes the gas take up space, that gives it its volume. And when you cool it down, they whiz around with much less energy, and so they take up less volume. And he realized that if it was cooled by 273 degrees, what went to zero was the energy. They had no energy, they were frozen solid. And so he called that absolute zero. And in honour of him, a new scale of temperature was created, which started at absolute zero and went up 1, 2, 3 in kelvins. So the boiling point of nitrogen is minus 196 Celsius, or 77 kelvins. When William died in 1907, he was buried at Westminster Abbey, next to Sir Isaac Newton. Very often I say goodbye to my heroes at their gravesides, but here in this cupboard I've got something much more interesting to show you. This is an experiment set up by Kelvin in 1872 and it's still running. Look at the bottom of this tube. You can see it's a lovely bright blue saturated copper sulfate. And when he first filled it, he filled it with saturated copper sulfate up to this mark. Look, saturated copper sulfate below, water above, filled October 24, 1872. And if you look up, you can see that the blue gets fainter and fainter until up at the top, 17.5 feet up, it still looks like pure water. What he wanted to find out was how long it would take for the blue to become uniform all the way up the tube. Well, it may not be terribly exciting, but it's almost certainly the world's longest running experiment. I don't know whether you've noticed, but an awful lot of my heroes seem to have had their inspiration on mountaintops. This is Ben Nevis, and my next hero won the Nobel Prize for the work he did after an inspiration he had up on the summit. He invented the cloud chamber, and his name was C.T.R. Wilson. Charles Thompson Rees Wilson was born at Glencorse in the Pentland Hills near Edinburgh, where his father was a progressive sheep farmer. Wilson went on to join the exciting group of young physicists in Cambridge. As a lecturer, Wilson was completely hopeless. He mumbled, he had a hesitant delivery, and his writing on the blackboard was completely illegible. But his skill and patience at research was unparalleled, and he was fascinated by meteorology. In June one year, Wilson was standing on the top of Carnmore Jarrick, which is a peak just over there, and he was looking towards Ben Nevis, and suddenly he felt the hair on his head literally stand on end. He ran for cover and just missed being caught by a violent thunderstorm, and he said it drew his attention very dramatically to the intense electric field produced in thunderstorms and also how rapidly they change. But it was his experience of 1894 that really changed his life. Right, here we are, the top. That's it, the top of Ben Nevis. 4,406 feet. It feels like about 4,000 miles. It must have taken me at least 5 hours to get to the top. Oh, wow. The trouble is, I climbed into clouds at about 2,000 feet and I haven't seen anything since. Visibility is about 50 yards or something like that. What is amazing is that on the top here 100 years ago there was not only a hotel, but also an observatory. This is the remains of the Meteorological Observatory, which was built in 1883, and people lived here and they took hourly observations for 21 years, and they sent them by telegraph via Fort William to all the meteorological stations in Europe. One of the people who was here in 1894 was C.T.R. Wilson, an assistant observer, and he was really fascinated by two particular things. One, when he looked at the sun, he saw coloured rings around the sun. And the other thing was, when he looked at his shadow on the mist, when there was mist below him in the valley, he saw coloured rings around his shadow, and he couldn't explain this. He was really mystified and decided to investigate it when he got back to Cambridge. Now the trouble was he couldn't easily get cloud in the lab in Cambridge, so he had to build himself a box to make clouds in other words, a cloud chamber. Unknown to Wilson, the new machine would take him far beyond the realm of circular rainbows. This is my cloud chamber, and I'm going to make some clouds right in here. And the reason you get clouds is that there's a lot of water vapour in the atmosphere, like there is around here, and if the pressure goes down or the temperature goes down, then the water begins to condense out into little droplets, and then it looks like cloud or mist or fog. So I'm going to lower the temperature by putting a little bit of dry ice. I've dragged this thermos of dry ice up here. I'll put a little bit in there, and that will cool it down. Wilson got mist and clouds all right, but was surprised when sometimes he saw little trails. Now sometimes when there's an aircraft going overhead, you see a vapour trail, and that was the sort of thing he was seeing in his cloud chamber. And he reckoned it must be tiny particles. He tried radioactive sources and they gave him little streams of particles. And he tried X-rays and they did too. And I've got here a little source of radioactive particles. You see that little blob there? That's a bit of radioactive lead with a bit sprouting towards you. So I'm going to put that in and see if I can get some little vapour trails coming from the radioactive particles. There we are. There's some trails there in my cloud chamber. He immediately realised how important this was. Rutherford had only recently suggested radioactive particles existed, shooting out of atoms as they broke down, but they were still controversial. Now Wilson had discovered a way to actually see them, or at least to see where they had been. By putting his cloud chamber in a magnet, Wilson could make the little particles curve to the left or to the right. By spotting their characteristic curved trails, he used the cloud chamber to identify the particles themselves. And that was why Wilson won the Nobel Prize in 1927. Lord Rutherford described the cloud chamber as the most original apparatus in the whole history of physics, and it was invented as a direct result of his experiences here on Ben Nevis by C.T.R. Wilson. Many of my heroes are loners, working on their own with inadequate resources. But these days, most effective research is done in universities or big industrial labs. So, it's rather surprising to find that one of the great inventions of this century was made by a man literally starving in a garret. Using his own pathetic finances, he beat the great organisations in many parts of the world to one of the holy grails of this century's engineering, which was sending moving pictures from one place to another. The man who invented television was born and raised in this very house in Helensburgh, northwest of Glasgow, and his name was John Logie Baird. Baird was a sickly boy and was affected by illness all his life. Maybe his recurring bronchitis, which cut short his attempts at more conventional careers, gave him time to pursue television. Even as a lad, he was always inventive. He probably got it from his dad, who'd actually built this speaking tube, because he worked upstairs and he told the family, "You must never ever disturb me. And if you absolutely have to speak to me, you must use this speaking tube." So of course John wanted one of his own, and he rigged up his own telephone exchange to speak to his friends, Wimpster, Bruce, Norwell and Wadsworth. And it worked well for ages, until one stormy night when one of the wires blew down so low it caught a passing cabman round the throat and lifted him clear out of his seat. John enrolled in the Royal Glasgow College of Technology to study electrical engineering. His old lab is still filled with amazing electrical gear, now part of Strathclyde University. A fellow student was John Reith, who was to play a crucial part in Baird's later life. The two didn't get on. Unfit for service when the war broke out in 1914, Baird spent his time instead maintaining the Glasgow electricity supply. After the war, his entrepreneurial streak came out. He set up right here at 17 Blairbeth Road. It must be here, this hole in the ground. Now, he didn't have a job, and so he had to turn to commerce. And he invented these Baird patent undersocks. Are they wonderful? And these were meant to be worn underneath your ordinary socks, and they kept your feet nice and dry and warm, and so they prevented rising damp. And he said they were soaked in borax, and this was particularly good at soaking up sweat or something like that. And he used to sell them with masses of testimonials like this from satisfied customers. "Please send me 6 pairs of Baird undersocks. They're the very things required out here." And these were entirely fictitious. He made the whole lot up. He actually hired sandwich women, the first ever sandwich women in Glasgow, who wore huge sandwich boards going around advertising these socks. It may sound really stupid, but at one point, with these socks, he was actually making £200 a week. Dogged by ill health, he set up instead in Trinidad, and then in London until he became so ill that he virtually retired to Hastings, aged 24. That was 1922, and Baird was probably already working on television, but at that point he decided to spend his life on it. Now, television is much more complicated than radio. With radio, in principle, all you need is a microphone. It'll pick up all the sound in the room. You can send the signal down a wire and transmit it over the airwaves, and then you can have the symphony orchestra in your sitting room. With television, it's a bit more difficult. You can use a photocell like this, and that'll pick up the light that's falling on it. And you can measure that with a meter like this. And if I cover it up, it gets dark, like that. But of course, this doesn't send a complicated picture. If you have the cup final going on and you have one of these, then all the people at the other end would get would be a single light bulb going on and off slowly, and it's not very exciting really. To get a complicated picture, you need thousands of these, one for each bit of the picture, and then you need to send all those signals. It would be very, very complicated over the airwaves. But there is a neat trick called scanning, where you divide the picture into bits, measure the brightness of each, and send all the bits of brightness information down the wire one after the other. If you can reassemble the picture quickly enough to fool the eye, you have television. In 1884, a German engineer called Paul Nipkow thought up a way of scanning a picture bit by bit. And what he did was to invent this, the Nipkow disc. And it's a great big disc, and it's got a spiral of holes drilled through it all the way around the edge. And if you look, you can see that they start at the outside and then they get further in. And that's the outside one and that's the inside one. Now, you look from that side, and I'll shine a light through the back, and you'll see how it works. As I move the disc up, you'll see that you get a bright line up the right-hand edge of your picture. And if I spin the disc round, you'll see that you get a succession of lines starting at the right-hand edge and then moving across. And so if you had a photocell where you are, then that would pick up all the separate bits of the picture one by one. And if only there were a way of reassembling all those bits in your sitting room, then you could have the cup final right there. Now this was roughly where Baird had got to by 1924. This is his camera, or his transmitter, as he called it. And basically, it uses a Nipkow disc. You can probably see the holes drilled near the edge there as I spin it round. And I'm going to take a picture of something on your side. Now, I'm going to drive the disc using this electric motor, which is actually a bicycle dynamo run in reverse. I'm using this because it gives me 750 revolutions a minute, which is what Baird used. And back here, I've got the photocell, which is going to pick up the signals, the light coming through the holes, and turn them into a signal and send them down this wire. OK, the first thing I have to do is to get the disc spinning. Bike dynamos aren't designed for this, which is why I have to give them a hand. There, that's lovely. Now what I need to do is to put a cover on, because the photocell is very sensitive and I don't want any stray light getting in. And so once I've put this over it, it won't be able to get any light onto the cell except what comes through this lens in the front. Next thing, my subject. I'm going to try and get a picture of this Maltese cross, because that was Baird's first subject too. And that wants to go down there in front of the lens, and then I need a bright light shining on the subject. And I should think that would be about perfect. Now, let's see what I can get in my receiver. Now this is my receiver, my telly if you like. He called it a televisor. And if you look, it's just another Nipkow disc, exactly the same, another gramophone record, and all the holes are exactly in sync with those. That one had a photocell to receive the light. This has a battery of light bulbs to transmit. They correspond to the photocell on that side. The photocell takes the light in, and these give it back out again. Look, if I put my hand over the lens here, it goes dark. Take it away, it goes bright. Dark, light. I'm using a bank of bulbs because one wasn't bright enough, but they are wound together and fade up and down like a single bulb. There isn't a picture until it's been through the Nipkow disc. So I've got my bank of bulbs flashing away at the back here, and I hope that my Nipkow disc will sort out the signal. So if you look in there, you should see a wonderful image. In 1924, Baird moved to London, and when Mr. Gordon Selfridge Jr. of the Selfridge's department store heard about the experiments, he suggested a public demonstration in the shop. He would pay Baird £25 a week for 3 weeks. It was the world's first public demonstration of television. Finally, on the 2nd of October 1925, Baird sat Bill, a ventriloquist's dummy, in front of the transmitter so that he could watch the televisor. What he saw was amazing, a face in real detail. The first person to appear on television was a lad called William Tainton. It was the 2nd of October 1925, and Baird had just got his system working, and he rushed downstairs to the floor below, and he found this office boy working there. He said, "Come upstairs, come and sit in this chair." And he sat him down, and he went and operated his machine, and he couldn't see anything. And he went back in, and he found that William had got so hot from the lights that he'd moved his chair back. So Baird gave him £0.50, and that solved the problem. He sat in front, and Baird shouted, "Open your mouth, shut your mouth, open your mouth, shut your mouth." And he was the first person, William Tainton, the first person to appear on television. Baird managed to send pictures through the telephone, and in 1928 across the Atlantic by radio. He became a bit of a celebrity, especially when he finally got the BBC to agree to a broadcast trial. Amazingly, they didn't seem to be interested at first. The Director General was the same John Reith who studied with Baird at Glasgow, and no one knows why he was so reluctant to give television a go. And here we are, look, a genuine televisor. J.L. Baird televisor, the eye of the world. So Baird had done it. Although most of the technology had actually been invented by other people, like the Nipkow disc, for example, he was the one who put it together. He made television work, despite enormous competition from huge corporations in America and elsewhere. On the 3rd of June 1931, he went to Epsom and televised the Derby, and he put one of these in 10 Downing Street for the Prime Minister, Ramsay MacDonald. And MacDonald instantly saw what television was all about, and he wrote to Baird and said, "When I look at the transmissions, I feel that a wonderful miracle is being done under my eyes. You have put in my room something which will never let me forget how strange is the world and how unknown."
Isn't that wonderful? Of course, the story didn't end there. We don't all watch mechanical television these days. We don't see the picture through a spinning disc. Even though Baird went on to develop colour television and three-dimensional television, there was another system being brought in at the same time. The cathode ray tube had been invented in 1897, and here at the back you can see a whole bunch of metal gubbins, which is actually the cathode, and when you heat it up, a stream of electrons, cathode rays, comes off and makes a bright spot on the screen in the front. And you can steer this stream of electrons and make it scan the picture, and because there are no moving parts, you can make it scan with very fine lines and very quickly, and so in principle it ought to have better resolution than a mechanical system. In 1937 there was a great twin trial. The Baird 240-line mechanical system was tested against the EMI Marconi 405-line system, which is much as you get on these tellies. This is a 1938 version, and unfortunately the electronics won, and so it was in 1937 that Baird television was turned off for the last time.
I'm sorry, that's all the heroes from this part of Scotland. See you next time! If you'd like to try some experiments from the programme or find out more about my heroes, details are on the Local Heroes website. You can write with your comments or suggestions to Local Heroes, BBC, 201 Wood Lane, London W12 7TS.
Next on BBC Two, tasting English wine on Food and Drink.